Hi, my name is Raghu Prabhu. I'm a Principal Data Lake Specialist in AWS. Welcome to this video. This video is the first of a two-part video series where I talk about data lakes. In this video, I talk about some of the common strategies that you can use while building data lakes on AWS. For example, in today's agenda, we will cover the general data strategy, a single account or a multi-account data strategy, a bucketing strategy, and also an encryption strategy. But first, we will get a quick overview of lakehouse architectures on AWS. My goal in this video is to explain some of the common architectural patterns I have seen given the time I've had this position. So I'll share some of those patterns with you, and I will also share some really good content that revolves around data lakes. I don't want to throw a lot of content for you to go and read. What I want to do is give you just enough content that I think is useful when it comes to building data lakes on AWS and does an extraordinary job in helping you come up with that end state architecture. But first, a lakehouse architecture on AWS. This is a typical architecture where you will use purpose-built database services to build purpose-built applications. So for the right application, you would use a relational database or a non-relational database or a time series database, or use a specialized service for machine learning. So when you build applications, they are all purpose-built applications that will use a purpose-built data store. So when you do that, it is fairly common for you to move data between those applications and between those data stores, and also get the data from those purpose-built applications and data stores into a common centralized storage service such as Amazon S3. In today's conversation, what I want to do is start off with a quick description of the circle in the middle that encompasses S3, lake formation, and also glue, and understand what a typical data lake architecture looks like on AWS that includes some of these services. So this is a typical data lake architecture when you build data lakes on AWS. So how does this architecture unfold? First of all, you would get data from various different data stores into a common centralized storage service such as S3. Once you get data into S3, you can get the schema off of this data and create metadata tables inside AWS Glue Data Catalog. AWS Glue Data Catalog is a Hive-compatible metadata store which will hold the schema of the data that is in S3, which is the centralized storage service for data lakes. The AWS Glue Data Catalog can also catalog other data sources, not just S3, but we will save that topic for another day, and there are plenty of Glue resources for you to know how you can use the Glue Data Catalog and catalog data that is beyond just S3. So we will save that conversation for another day. But coming back to this, schema goes into AWS Glue Data Catalog, data is in S3. At this point, you can spin up many purpose-built analytics services or machine learning services to monetize your investment in data. We have an ETL service for interactive querying. You can use Amazon Athena. For big data, you can use Amazon EMR. For data warehousing, you can use Redshift or Redshift Spectrum. And of course, for BI and analytics, QuickSight, and for ML services, you can use SageMaker and many of the other purpose-built ML API-driven services that we have. So in August, I think in August of 2019, we released a very interesting service called AWS Lake Formation. And please look at the way this particular rectangle is placed. To the left of this, you have the metadata store and you have the data itself. And to the right, you have consumption services. So there are many goals that lake formation has, and it solves many of your common data challenges. So let's quickly review this and get a baseline for today's conversation. One of the first challenge is to be that security and governance layer. Challenge number 2 is to manage S3 permissions for analytics. I will have a separate video, the series 2, video 2 of the series. I will cover how these two challenges actually work together. And then challenge number 3 is lake formation also has functionality that will help you with data ingestion. A common challenge is to share databases and tables across AWS accounts. So if you want to share data from one AWS account to another AWS account, how do you do that? Lake formation helps you solve that problem. Again, I will cover this in my next video. And finally, what about data compaction, data acceleration? Some of these are some of the many challenges that lake formation is solving quite nicely. We have a preview open for data compaction and data acceleration, and I will have the link for that in the comment section, so please do check it out. Okay, so this is a quick baseline for today's conversation, and today we're gonna cover everything to the left, of lake formation and glue. So it's multi-account strategies, bucketing strategies, data strategies, and encryption strategies. So let's get started. So when you build data lakes on AWS, Amazon S3 is a very common and a popular choice. And why is that? Well, for all the reasons that are in front of us. And we have plenty of material available that talks about high availability, durability, how S3 is serverless. It offers unlimited storage. But what I want to do is talk about these bottom 3 features of S3, which I don't think we talk enough about. Number 1. Number 2, these bottom 3 are very much related to data lakes, and the architectural considerations that you have to make when you build data lakes on Amazon S3. So today I will cover the high throughput nature of S3, how S3 can be cheap and cost effective, and finally my number 1 favorite re:Invent announcement, which is S3 being offering a consistent view. First of all, let's talk about how S3 is high throughput. What I have done here is, like I said, I will be providing some links to certain content which I have found very useful when you build data lakes on AWS. So this is one of the first ones. This is a video that we have for re:Invent 2018 that talks about many things that we released that year for S3. I have bookmarked this link for the high throughput conversation. When we get to the high throughput part of the presentation in the video, that's what this is bookmarked for. Let me just quickly read out what's in front of our screen. Since this release, Amazon S3 offers 3,500 write transactions per second and 5,500 read transactions per second per partition. What does this partition mean? I will have you go through this video because this will explain what this partition is. It's very different than a Hive style partition. It's very different. So definitely pay attention to this video. It explains what the partitions really are for S3 and how to scale them and what these transactions per second actually mean. And then 99.9% of customers no longer need hashing. This is quite interesting because if you don't know what hashing is, well, you don't have to ever know because of the high throughput nature of S3. And if you knew what hashing is, then I'm sure you will appreciate the high throughputness of S3, so you don't have to worry about it anymore. Then next link This is a link to a white paper that I have found to be quite useful when you are ingesting large amount of data on S3. So I highly recommend, between these two pieces of content, you will learn a lot. So definitely, check them out. And then couple more links. Cost optimization. How do you control costs on S3? This is a link to a blog post, which I found to be quite useful. And then finally, like I said, the consistent view. Now that's a standard feature in S3. Again, this is the reInvent 2020 announcement, and here's the link for you to go and research. Perfect. So I just offered you about 4 different resources that I think do an excellent job when it comes to building data lakes on Amazon S3. But now what I want to do is very quickly share some of the common practices that I have seen out in the field that our customers use constantly and have proven to work quite well. Let's talk about different data stages when you build data lakes on Amazon S3. What you see here, I call this a textbook data lake layer. Okay, we have 4 different zones: the landing zone, the raw zone, the curated zone, and the aggregated zone. What do these zones really mean? First is the landing zone. When you build data lakes, you are to bring data from various different data sources and land them on S3. You could be bringing data from databases, streaming solutions, any number of those solutions that you would want to ingest data from. You can bring that data and land them on S3, and that makes it a landing zone. You will bring this data as is, meaning if the data ingested is in JSON, you will leave them in the JSON format. If it is XML, you will ingest data and land data in XML, so on and so forth. Once you land this data, now you are getting it ready to move this data through the pipeline. Okay, so the next layer, you would be transforming the data that you have just landed would be into the raw layer. So what is the raw layer? The raw layer is very much like the landing layer, but minus some data. Okay, if you have data that is truly sensitive and it is better off not carried forward, you would just leave the data in landing. Or if you have data that is not useful at all, again, you will not carry that data into the forward zones. So as you move data from landing to raw, you will most likely drop some data, and at the same time convert the file format from whatever the file format you have ingested data into a more columnar format such as Parquet or ORC. So the raw data, you will start using more columnar data formats minus some data, and from raw you will move data into curated layer. So what's the difference between raw and curated? Curated layer is the actual layer where you will be doing most of your analytics. Okay, so in the raw layer, which is very much like the landing layer, but with some core differences that I've mentioned previously, you will have an ETL process that will take the data and you will join the data with multiple different tables. For example, you may take the sales data and join it with customer data and the marketing data. You will also normalize and standardize the data as you move this from the raw layer into the curated layer. So this way the data is a lot more flattened, which will reduce the amount of joins that you would have to do in the curated layer. And also you will normalize and standardize the data as well. So the curated layer is the layer that you will provide access to for general purpose analytics and general purpose machine learning. So this will be one of your most used zones for analytics and machine learning. Landing and raw zone are purely for ingestion purposes. And if you And it also serves another purpose, which is if you want to rerun any of those processes, let's assume the ETL process was not run properly and you want to rerun some of this data, you always have access to this data and you can rerun the data from landing to raw or from raw to curated. So that's the role of landing and raw. The curated and aggregated zones are mostly for analytics. Now, what is the aggregated zone? An aggregated zone is all the data that is in curated but aggregated to a particular dimension. For example, I'll just give you one example. If you are a banking customer, you would want to see daily averages at the account level. You may also want to see daily and monthly averages at the branch level. So instead of having your users constantly run group by statements for aggregations, some customers create an aggregated zone with all the aggregations already pre-done, so you're not running the same queries over and over again. So this is the textbook data layer, like I said, landing, raw, curated, and aggregated. And of course, as you move through the pipeline, you will see that the files are getting a little bigger. It is recommended that you use columnar data formats, and chances are even the file sizes is increasing, which also helps with performance. But you don't have to do the textbook data lake zones. At a minimum, you just need 2 zones. Some of our customers may skip the raw, and some of our customers may skip the aggregated. So it really becomes landing and curated. So at a minimum, please know that you will need 2 layers. Great. Let's talk a little bit about data sensitivity and how it affects your data strategy. So again, going back to the 4 zones, landing, raw, curated, and aggregated, knowing that curated and aggregated are the more popular zones for analytics and machine learning, you will be opening up access to curated and aggregated to your user base. With that said, when you centralize this data in a common data store, which is wonderful, but it also creates another problem. And that problem is, how do you control access to your most sensitive data? So you will start thinking about data sensitivity, and you will also start thinking about user personas who should be accessing or not having access to this data, which leads to data tiering. On the screen, what I have done is I have shown, tier 1, tier 2, and tier N. I have seen customers with just 2 tiers sometimes. I have seen customers with 5 or more tiers, or 3 to 4 tiers is also fairly common. And I have put the tiers underneath the curated and aggregated, but not under landing and raw. And that's because landing and raw are purely for ingestion. Curated and aggregated are made for consumption, for analytics and machine learning use cases. So what are these data tiers and why are they important? As you start thinking about data sensitivity, you will understand that there are different types of user personas in your organization who will access this data. And you will also start thinking about the data sensitivity mapping to those user personas. So user base 1 may get access to all the tiers. User persona 2 may get access to maybe just tier 2, so on and so forth. So what will happen is you will start creating multiple copies of the same data, where tier 1 will have all the data, including the sensitive data. Tier 2 may have some retracted data, but also may have some sensitive data, and tier 3 and 4 and 5 will just have more retraction, data masked, tokenized. And as you go up the tiers, you will have the least sensitive data, and chances are the user base also gets bigger, which again means fewer users will have access to the lowest tier because it will have the highest sensitive data, and most users will have access to the highest tier because it has the least sensitive data. The point that I would like to make, again, I will cover this in my talk too. You no longer need these tiers if you're using lake formation. But right now I'm just talking about data strategy, and it is common for our customers to create these tiers. So it is good for you to know that if you're thinking along this direction, it's okay to think that way because it is a practice, but also know that you can significantly reduce the complexity of having all these different tiers and having to copy data across all these tiers. You can significantly reduce this complexity by the usage of lake formation. And again, I will have a deeper discussion about this in my video number 2. All right, let's talk about your AWS account strategy. As you build data lakes on AWS, how do you think about your account strategy? How many accounts should you have as part of your data lake initiative? Is one account good enough, or should you always have a multi-account? This is a very popular discussion, and what I would like to do is share my field experience with you, and I really hope it helps. All right, let's sort of break this down. When you build data lakes, you would be doing 4 different types of activities. You will ingest data, you will store data, you will apply security on top of this data, then you will open this data up for consumption, analytics and machine learning. So there are 4 different activities that you engage in when you build data lakes on AWS. These are some of the common services that you use for data ingestion. Glue ETL, EMR are popular choices. We got plenty of partners that will help you with data ingestion. For storage, Amazon S3 is the most popular choice. For data lake security, it's usually a combination of AWS Glue Data Catalog and AWS Lake Formation. And of course, for endless services for data consumption, we have all of our own AWS native services and also partners. So how do you think about all these 4 different activities when it comes to your account strategy? You could wrap everything into one AWS account, or you can put data ingestion and data storage into one AWS account, and you can call this to be the storage account. You can have a separate account for security and governance. And you can have different accounts for data consumption. So this is a true separation of data, data lake security, and consumption. And another point to make here is you can have multiples of the storage accounts and you can have multiples of the consumption account, but you are more likely to have one and only one data lake security account. Again, more on this later, but I just want you to see how this architecture is going to unfold between a single AWS account architecture to a multi-AWS account architecture. Still, let me tell you some of the things that you have to think about when you make this decision. Let me go through this list. But still, how many accounts should you use for data lakes? Are you a customer that is more suited for a single account strategy or a multi-account strategy? And it really depends on some of these common questions. Number one, it really truly depends on the culture of your organization. It also depends on how your IT teams are set up within your organization. It also depends on the number of lines of businesses or business units that you have in your organization. And it's also important to look into if these lines of businesses operate as independent entities. It depends whether your IT is split across those lines of businesses or if your IT is more centralized. It again depends how well staffed any of these IT teams are and how well staffed your IT security teams are. It also depends on your data integration team or your ETL team, if it is more central or if it is more split across multiple lines of businesses. Do you do chargebacks for your line of business, meaning every line of business in your organization is run like its own business with its own P&L, profit and loss, and therefore they get charged back to their AWS usage? Is that a common practice? And then finally, how data-driven do you really want to be? If you're thinking about data lakes, it's a little bit of commitment. Okay, you need to commit resources as in terms of people, infrastructure, maintenance. So there you will be embarking on a journey that will fuel the next how many ever years of your innovation and product pipelines. So therefore, it is a commitment, and I really want our customers to think about how data-driven do you really want to be, and make sure that you are well-funded to embark on this type of a journey. But like I said, I do want to be prescriptive here. I want to provide you with very clear guidance. So when I'm talking to my customers, I have just 3 basic questions to decide if they are a candidate for a multi-account strategies. So let me just go through these questions. Do lines of businesses operate as independent entities? Let's assume the answer is a yes. Do you have one single data integration or an ETL team, or if that is split across multiple lines of businesses? Let's assume it's decentralized, it's more split. Do these lines of businesses pay for their own AWS usage? If, let's again assume is a yes. If 2 out of the 3 questions are in the ballpark of how these responses are, chances are you are a better candidate for a multi-account data strategy. But still, you know, I do get asked, how many accounts should they really bring into their data lake strategy? Well, here's a rule of thumb. If you have 5 lines of businesses, let's assume you have 5 lines of businesses, you will at a minimum have 5 accounts as part of your data lake strategy, as part of your data lake initiative. You will have at least 5 accounts, 1 account for each line of business. That said, for any compliance reasons, you cannot have conflicting data in the same account, and you just need to have 2 different accounts. In that case, you will have 10 accounts as part of this data lake initiative. I hope that starts making sense here, how we go about this. More on this later, and also, like I said, my part 2 of this video series will also get into this quite a bit. Now, are you a good candidate for a single AWS account strategy? Here are the 3 questions that I usually ask. Do you have a central IT, or IT is split across different lines of businesses? Let's assume it's more central. I see a lot of this too. It could be a large customer with multiple lines of businesses, but the culture of the company is such that the IT is more centralized. Similarly, what about how well staffed your IT department is, and how well staffed your IT security team is? And again, let's assume if that's a yes, I do see a lot of this, which, you know, the more central IT gets and IT security gets, they just have more resources. It's properly staffed. And let's assume that's the case. Do you have one single ETL team, or if ETL teams are split across, you know, multiple lines of businesses? Chances are, if IT is more centralized, I have seen even ETL becomes more centralized. So as you can see, the culture of this company is more centralization. So even if 2 out of these 3 questions are, if you have answered them much along the lines like what you see on the screen, then chances are a single AWS account strategy may work well for you. But then again, I just want to give you a little bit more data, so you choose you make this decision with some thought behind it. So what I have here is some criteria, and then single account versus multi-account. Okay, getting started. If you're just getting started, and if you're just embarking on a MVP, a single account strategy is always very simple. Multi-account strategy is slightly complex. Control off the data lake. Easier to control and monitor because everything is in a single account. If you have a multi-account strategy, to make sure that you have proper control over all those accounts, you will have to do a fair amount of automation so you can deploy infrastructure. And that's best done when you automate such activities. Speed of the data lake growth. What I have seen is if you have a single account strategy, and if the rate of your data lake growth is high, or at least high for you, or how well staffed your team is, a single account strategy can bottleneck the growth of the data lake because there are not many people to support you. In a more decentralized or a multi-account strategy, chances are that you will be able to sustain growth a lot better. Company size. For smaller organizations, with fewer lines of businesses or maybe just one line of business, chances are single AWS account strategy is perfectly fine. That being said, I must tell you, if you are a team inside a much bigger organization, and if multi-account strategy is going to be an overkill because this is just for you, your team, chances are single account strategy is going to be good enough for you. A multi-account strategy is perfect for large organizations with many different lines of businesses. Cost allocation and chargebacks. If you want to do chargebacks for different teams in a single AWS account, you will have to make sure you are diligent about using tags so you can do proper chargebacks based on the detailed billing report. In a multi-account strategy, it's significantly easier because you have separate accounts anyway. Flexibility of design. In a single account strategy, as everything is more centralized, there will be a lot more rules, that you have to follow. Ingestion needs to be done a certain way, and everyone's going to have to kind of play by the rules because you're all sharing one piece of infrastructure. In a multi-account strategy, you can be very, very flexible. Every team or line of business can bring their own ingestion mechanism if they want to, and just when they are ready to contribute their data into the data lake, they just have to make sure they follow the best practice and use the common interfaces as they share this data into the data lake, and that's the case with the multi-account strategy. Cost is the same across either of them because it doesn't cost for you to create more accounts. Okay, so again, I just want to, having said all that, I just want you guys to look at the single account strategy and the multi-account strategy, so you sort of find yourself in either of these common patterns. Finally, if you can't decide if you're a single account strategy or a multi-account strategy, I must tell you, don't sweat it. Don't worry about it, because chances are you cannot decide this right now because you are on a MVP or a POC stage. Go with the easiest option, which would be a single account strategy. Go with the MVP, go with the POC, and see how you do. Okay, I would much rather have you be successful, get a ton of feedback as you launch these programs, these data lakes in your organization, and then make your own decision whether you are a single account type of an organization or a multi-account type of an organization. And at the end of the day, if you want to break a single account into a multi-account data lake, it's really, really not that hard. It can be done fairly easily. or if you want to collapse a multi-account data strategy into a single account, that also can be done. So feel free to start somewhere and be open to learn. Use the feedback, and if you have to change your decision on your account strategy, it's fairly common, and it does happen. So don't worry about it. If you can't decide, go with the easiest option, and that is the single account strategy. All right, let's talk about buckets. So far we have discussed the data strategy, when you build data lakes on AWS. But what about buckets? What about how many buckets? Is there a best practice architecture that you can use to decide how many buckets are good for you? The answer lies again in you as an organization. You can create as few buckets as possible and create multiple subfolders underneath them, or you can create as many buckets as possible. What I want to provide you is a few things to consider as you come up with your bucket strategy. All right, so let's kind of get into it. A bucket strategy. As you know, Amazon S3 is an object store. You will have buckets. Buckets will have subfolders. We call them prefixes, and you can have a hierarchy of prefixes. There is one thing true when it comes to a bucket, and it's that it has a bucket policy attached to it. Bucket policy is written in JSON. It's very flexible, and sometimes that can make things very difficult because you can write any type of policy, and sometimes reading those policies are like doing mental gymnastics. So they can get very difficult to understand what is going on in those policies. All right. So the way I'm trying to approach this bucketing strategy is from reducing the complexity when it comes to bucket policy management. If you come up with a bucket strategy that is easy, then chances are you will scale your data lakes far more easier. So let's go through the next series of slides very quickly. Same concept, right? You're going to have a bucket. You can have multiple subfolders. It doesn't matter. You just have one policy to work with, which kind of looks like this, and that's kind of hard to read. So still, how many buckets? One thing that I did mention is think about how you can arrive at a bucket strategy by making it less work for you to manage the bucket policy. There are a few other considerations for you when you make this decision, and I have the top 4. These top 4 considerations are at the bucket level. Okay, these are bucket level settings, which means once you set this at the bucket level, it will apply to all the subfolders or prefixes underneath that bucket and all the objects underneath that bucket. Just as the policy is at the bucket level, which applies it to, and that policy applies to all the subfolders and all the objects. Similarly, these are some of the common features for a bucket that you need to consider while you come up with your bucket strategy. Number 1, bucket level encryption. Once you set this at the bucket level, it sort of flows for the entire bucket. Bucket versioning, intelligent tier archive, basically data archiving configurations that applies to the entire bucket. Requester pays. This is again a very common pattern. If you want the requester to pay for their usage, this again is a bucket level setting, which means all the prefixes and all the objects underneath that bucket will have to this rule will apply to all the other objects underneath it. There are a few other considerations for you, which is object locking. Definitely look into that. There are some legal considerations when it comes to object locking. Then, of course, server access logging and CloudTrail logging. So I have about 7 different features at the bucket level, and which will apply to the entire bucket just as the policy. And I request you to consider all these different features when you come up with your bucket strategy. But like I said, I do want to be a little prescriptive, and I have seen when things become very, very complicated. Okay, so I would say let's just avoid the following. You have seen the different data sensitivity tiers in the previous slide. Let's assume you have one bucket with multiple tiers underneath that bucket. All right, so tier 1 through tier n, and like I said, you could have as at a minimum 2 tiers, at a minimum just 1 tier. I do see very commonly, about 3 tiers in some organizations, and I have also seen up to 5 tiers as well. So let's assume all these data sensitivity tiers are under just one bucket, which means they are bound to one bucket policy. Okay. And just to keep things simple, let's assume there are just 3 tables, and these 3 tables are nothing but prefixes underneath each of those tiers: customer, sales, and products. Tier 1 will have all the data, which means it can be as sensitive as you would want it to be, and tier n will have the least sensitive data. Okay. If all this data is underneath just one bucket, imagine what this policy is going to look like. It will be very complex because now you have user personas, and you have to map user personas to different tiers. And within each persona, you may have sub personas where maybe some of your users cannot access the sales data, but just the customers and products data. So if you consider all the complexities that you would have to code into the policy across all the different tiers, your bucket policy is going to be quite complicated. So what I would request, instead do this. If you feel that if you work backwards from the user persona, but not just user persona, even the applications that access this data, if you work backwards from what is accessing this data and how to minimize the complexity of these bucket policies, you will see that you will come up with a bucket strategy, and you're more likely to have multiple buckets based on the type of data it is going to hold. So again, what I want you to understand is work backwards from, at a minimum, the bucket policy. Okay, at a minimum, if you work backwards from bucket policy and how you want to minimize the operations of those bucket policies, then you will arrive at data sensitivity, and you will also arrive at user personas, and that will drive the right bucket strategy for you. Let's talk about encryption. AWS Key Management Service is the most popular service when it comes to encryption. And with that, I present you this one particular blog post, which is fantastic, that talks about, data lakes and encryption and different strategies that go with it. Again, I will have this in the comment section, so don't worry about this. So, but definitely read that blog post. Let's get a baseline really quickly. So we do recommend that you encrypt everything. There is no doubt about it. But if you were to encrypt everything using the most popular service such as KMS, what would you have to deal with in terms of cost? So I'll take a simple example. Let's assume there are 1 million KMS encrypted objects. And these million KMS encrypted objects are being read by a service. In this case, I'm using EC2. It could be Athena, EMR, anything, right? But something is reading 1 million KMS encrypted objects, which means you would have to decrypt them, and you are more likely to issue about 1 million decrypt KMS calls. So what will that cost you? KMS does have a free tier, but let's just assume you're outside the free tier. If you just do this math, you will see that this 1 million object reads cost you just $3 in just KMS. That's just KMS cost. What if you are to do this 10,000 times? If you do the math, that can become a significant amount of cost just on KMS. So a few facts to know, and not many customers remember this. They know this, but they don't remember it. KMS cost is not about file sizes. It's about the number of files. So it could be 10 megs of data, 10 MB of data, but if it is spread across a million objects, it's going to cost you a significant amount of money just to decrypt those objects. But if the same data is wrapped in one Parquet file, it'll cost you absolutely not much money at all. So it's not about how big these files are, it's about how many files there are. So if you have smaller files, which may mean many files, that would lead to expensive KMS. And of course, the opposite is true. If you have bigger files, then chances are you will have fewer files, and that's cheaper KMS. But I want to be prescriptive and give you a couple of options here. All right. Number one, I feel our customers have forgotten how awesome server-side encryption S3 is. Okay, this is SSE S3. This is encryption option not dependent on KMS. It is an encryption option provided by S3. It's completely free. There is no cost to this. And here's the link that talks most about this. So explore this. If you really don't need KMS and don't have to have KMS be the service to encrypt, because if you're looking for encryption at rest, this is an awesome solution, so feel free to explore this. Next, server-side encryption KMS bucket key. This is dependent on KMS but can reduce KMS API calls by 99%. Again, I have the link here that talks perfectly about how this works behind the scenes, and I'm not going to get into it. But this, again, was announced in reInvent 2020. This is my second most favorite release announcement of reInvent 2020. I cannot explain how significant this is. So if you're a customer who likes KMS and likes to encrypt everything, which is what you should do, but if you're worried about cost, check out server-side encryption SSE KMS bucket key. It is amazing. It's a wonderful release. Definitely check it out. Let me bring back my textbook data lake. Okay, I just want you to think about this. So we got landing, raw, curated, aggregated. We know what these are. What I want to point out is something that I have said before. Landing and raw may have smaller files and a lot of files, but you are less likely to open this up for general access because general access is on curated and aggregated zones, right? So who is accessing landing and raw? Landing and raw is being accessed by data ingestion jobs, ETL jobs that ingest data into landing, ETL jobs that move data from landing to raw. Chances are you can go with cheaper options for your encryption in landing and raw. And as you get into the higher tiers, which is curated and aggregated, and you have different teams doing different things, and if you want to have different keys to encrypt that, you can get as fancy as you want here in the curated and aggregated and come up with the right encryption strategy given the couple of options in the previous screen. But again, really truly look into your landing and raw, which can become expensive because you will have too many files and a lot of little files. Come up with the right encryption strategy so you can keep your encryption costs low and use the right encryption strategy for the right tier. That being my point. So that's my talk about some of the architectural strategies when you build data lakes on AWS. Again, this is a part 1 of a 2-part video series. In my second part, I will cover how lake formation simplifies a lot of things that we talked today, in fact. But as a pure data strategy, it's good to know your options. Check out the comment section because, or the description section, I must say. The description section will have all the links that I've been talking about. Check those resources out. And I'm optimistic that just these handful of resources, couple of days worth of research, I think it will go a long way in helping you make your architectural decisions when you build data lakes on AWS. Thank you so much for your time.